Hey everybody, this is Alex Merced, and welcome to another episode of Gnarly Data Waves. And in this episode, we're going to be talking about versioning data in the data lakehouse. So differences between like file, table, catalog versioning, the pros and cons, and all that fun stuff. So before we get into that, what I want to make sure we do is talk about the data lakehouse and how you can get your hands on trying out the data lakehouse. Because the data lakehouse is cool. It's going to make your data easier to access, faster to access, and accessible in more places by being an open platform. So try out the Dremio Lakehouse by heading over to dremio.com and clicking that test drive button so that way you can get hands-on with the Dremio platform. Also, make sure to pick up an early copy of Apache Iceberg, the definitive guide. Just scan that QR code right there. And also make sure to stick around every week at the same bad time, same bad place to catch more great episodes of Gnarly Data Waves. Next week, we'll be talking about Merce's journey to unified analytics with Dremio and generative AI. Then we'll have Apache Iceberg office hours. Then we're going to have a couple other episodes, which we are yet to announce, but keep an eye out for it. And then we'll also have an episode on Dremio and DuckDB in the late August. Okay, Dremio is also going to be present at many events all around the world. So if you had any of these events, whether they're these AWS events in New York, Coalesced by DBT in San Diego in October, Big Data London in September, Big Data and AI Paris in September, make sure to check out the Dremio booth or check out Dremio at all of these events. And with no further ado, we'll get into the main topic of today, which will be a presentation I will be doing. Okay, so I will be your presenter today. We'll be talking about versioning data in the data lakehouse, file, table, and catalog versioning. With no further ado, let's have the presentation begin. Okay, so here we go. The ins and outs of data lakehouse versioning at the file, table, and catalog level. This is going to be a topic that is really important because right now we're trying to really achieve this idea of the data lakehouse, which we'll get into in just a moment. But first off, let me just reintroduce myself again. My name is Alex Merced. I'm a developer advocate here at Dremio. Okay, I'll let you read the bio on your own time. We'll be part of the recording, but that's who I am. I'm Alex Merced, developer advocate here at Dremio. Also a co-author of Apache Iceberg, the definitive guide. You can scan that QR code in order to get an early copy of the book. And also the host of several podcasts, a host of Gnarly Data Waves, which you're watching this presentation on. Okay, I also do a podcast with my colleague here at Dremio, Dipankar Mazumdar, Select Star from Data Lake, which you can find anywhere podcasts are hosted. And then I also do a solo podcast, Data Nation, where I just talk about different data concepts. All of these podcasts can be found on Spotify and iTunes. Subscribe to hear lots more great data content. Okay. Well, with no further ado, before we start getting into the nit and grit of the presentation, I just want to mention that for this particular presentation, we're going to handle questions a little bit differently. So do leave your questions in the Q&A box down below. Okay. But what's going to happen is that I will be doing the questions asynchronously after this presentation. So I'll be recording an additional video going over all the questions that are submitted, and that video will be sent out to all the registrants post presentation once I record the answers. Okay. Because actually today, or during the time of this, I will be at my sister's wedding. Okay. So let's go on with the presentation. Okay. So the data lakehouse. Now, what is this whole evolution of a data lakehouse? So for the longest time, we've had data lakes. And basically, the paradigm of a data lake is just the idea that you have this one sort of repository where you're going to store all your data, structured or unstructured, and you can do sort of ad hoc analytics on it. And generally, you'll probably move like a subset of that data for more sensitive analytics to like a data warehouse. And that's generally been the way things are done. Okay, you ETL the data to the data lake, and then you take some of it and you move it to the data warehouse. So generally, like the tools you've had on the data lake, for compute, for running analytics, were generally read-only. You would read the data, run analytics on the data, but you weren't necessarily doing a lot of your transformation work directly from the data lakehouse. Usually you'd either do that in the ETL job that moves the data to the lakehouse, or during the ETL job that moves your data to the data warehouse. Otherwise, it was just a lot of read-only kind of stuff. And you're not necessarily curating further data sets from there, like you would in a data warehouse where you create marts and create different sort of derived views and whatnot. Okay, well, the data lakehouse really kind of changes what's possible in the data lake. Okay, so essentially, what it does, it makes it possible where you can do most of what you can do in a data warehouse, and some things that you couldn't do in a data warehouse straight from your data lake. Okay. And the big thing that sort of adds this layer is the table format. Okay. The table format is what allows that sea of files that's sitting in your data lake to be treated like database tables. Okay. So that way you can run SQL statements against them, be able to do DML, not just read, but write, and be able to do it performantly with ACID guarantees, with time travel, with all sorts of other really nice benefits. It's the table format that really makes this possible, this sort of independent metadata layer. And then those tables that use this table format can then be discoverable to your compute tools using a catalog. So that combination of a table format, so that way individual data sets can be recognized as tables, and catalogs in order to make those data sets discoverable, these two things together really make a data lakehouse a data lakehouse. Okay, because oftentimes the table format, again, makes the tables discoverable, but the catalog not only makes, or the table format makes the tables work like tables and the catalog makes them discoverable, but oftentimes the catalog can go further and provide different types of maintenance and portability and other benefits, really creating a robust sort of work place for your data. Okay, so we want to do more and more in the data lakehouse, but in that case, we need more and more tools that allow us to do things like disaster control, because sometimes mistakes happen. Okay, and you might want to roll back your data. I can roll back an individual table, and that's kind of part of what we're talking about today. But what are these mechanisms? Usually these mechanisms, when we talk about like code, is done through like Git, where we basically, hey, if we make a mistake, we would roll back to a previous commit. But when it comes to data, do we have mechanisms like that that are these versioning mechanisms? And there's actually many, especially if you're used to working with iceberg tables, and we're going to talk about them today. Versioning mechanisms. Okay, and this is all part of a bigger trend called data as code. So this whole trend, data as code, is the whole idea of just taking more sort of software development, CI/CD, versioning type practices and bringing them over to data. Okay, so again, like talking about Git, in Git, every time you would make changes to your code, you create a commit, and then you can make branches of commits, so that way you can have branching changes to your code that don't interfere with each other. And then, if that branch of code changes, something that you would like to keep in your mainline code, you can then merge those commits into your main branch. Or you could tag particular commits so that way you can easily reproduce them. So that way, if I need to run tests against that particular state of the code, I can then tag a particular commit, and then I can easily reference that commit whenever I need to. So these are all things that were possible with software development, with writing code, that versioning tools, like the ones we're going to talk about today, bring to your data. And the benefits of this are, well, the following, okay? Because you have versioning, you're gonna be able to do isolation. So if I need to isolate experimentation, if I need to isolate ETL work, ingestion, all of that can be isolated on individual branches, so that way they're not interfering with sort of my mainline data without necessarily having to create full copies of my data. Okay, multi-table transactions, because some versioning tools will make it possible to isolate those changes, but you'll be able to make changes to multiple tables within that isolated environment, and then merge the changes to multiple tables in a consistent way. So multi-table transactions, being able to kind of make changes to multiple tables, but still maintain consistency, because you're making all those changes appear to your analytical users at the same time. Okay, rollbacks. The idea that, hey, I made a mistake and I want to go back to a previous state of my data. Can I roll back to a previous commit? Reproducibility. This is where tagging comes in, where I can tag particular states of my table, of my catalog, of my files, and say, hey, can I go back to that? And then consistency, quality, and data validation. Because I have isolation, I have a space where I can, go make sure the data is consistent. I can go test for data quality, test for data validation before I publish those changes to my end users, instead of having to like ingest the data and try to test as fast as I can before the analysts use the data too much. I can isolate all those changes, make sure those changes are correct, consistent, quality, and then again merge those changes in there. Okay, so I get all these benefits because I'm using versioning as part of my arsenal in this whole data as code trend. Now, there's different mechanisms on where you can do versioning. Okay, so the idea is you're just capturing the different state of things at different points in time, but there are different ways you can do it. Now, if you're using Apache Iceberg, you're really going to have three ways you can do it. You can do catalog level versioning using a catalog called projectnessie. Okay, it's an open source project that allows you to capture versions of your entire catalog of tables, but you can also capture versions at an individual table level because the table format Apache Iceberg does have branching and merging at the table level built in. And then also there's this other project, LakeFS, that allows you to to version your file system of your Lakehouse. Okay, so all three of these provide you an approach to capturing different states of your data at different points for you to be able to get these benefits. Some will provide more or less benefits in certain areas or different use cases. It depends on what your use cases are, which of these are going to be sort of the best mechanisms, whether you need multiples of these mechanisms. But let's go over them. So first is catalog level versioning. So that's what projectnessie does. So essentially what Nessie is doing is that it's capturing references. Okay, so essentially the state of the catalog is just essentially a laundry list of references for each item that's on there. So which could be a table, could be a view, could be a whatnot. So essentially here we'll say we have three tables that are currently part of the catalog, and table A references snapshot 1, table B references snapshot 1 for that table, and table C references the first snapshot for that table. So these are three new tables. Now a change occurs, so another commit is submitted to the catalog. So now when the catalog looks at its list of tables, it says, okay, well, table B now points to a second snapshot, which then has the location of where that snapshot can be found. Well, as you can see here, each commit captures the state of all the tables. So this allows me, if I need to do a rollback, I don't have to do a rollback for each individual table. I can just roll back the entire catalog, okay? And then basically I can say, hey, go back to this commit, and then all the tables will be pointing to the snapshots that were relevant at that time. Okay, so it just allows me to work at a catalog scale versus at an individual table scale. And like the picture before, with this I can do branching, I can do tagging, so I can make branching trails of commits, tag individual commits for reproducibility, all that fine and good stuff. So a lot of the benefits you get from using catalog level versioning include multi-table transactions, because you can branch the catalog, make a bunch of changes to multiple tables on that branch, and then merge in that commit back into your mainline data. Multi-table tagging, because when you tag, you're tagging a commit of the catalog. So instead of having to create tags for a bunch of individual tables and then call each table by its tag, you can just say, hey, I'm using the catalog as of this tag that represents the whole state of the whole catalog of multiple tables. So essentially, you're capturing that reproducible state for the whole catalog. Multi-table rollbacks. Okay, so instead of having to roll back each individual table, you can roll back the entire catalog. You have branching and merging, so that way I can again isolate ingestion or create a branch for the purposes of experimentation. And again, when you create a branch, it's not a copy. Okay, you're not duplicating any data files. It's just that now any changes, it creates a separate path of changes going forward. And so that way people can do experimentation with the data without necessarily having to create copies in a safe way. Another neat thing with Nessie is that all these operations, so basically you can create a branch, do work on the branch, merge the branch all through your SQL. You could also use the Nessie REST API and also the PyNessie Python library to work with Nessie. But very, very unique is its ability to kind of do the full lifecycle all through SQL. Okay, so you never have to jump outside of SQL to do anything with Nessie, whether that's creating branches, switching between branches, merging, and so forth. It has a lightweight architecture, and what I mean there is that since it's not capturing it's not capturing the changes to every individual file and table, it's not capturing every change to every individual metadata file and table, just to that core metadata file for an Apache Iceberg table. Okay, so that means if I have a table of 100, if I have a catalog of 100 tables, I'm only capturing 100 references, and that's essentially the extent of what Nessie's tracking. This allows it to track, since it's tracking a lot less information per commit, it can handle a lot more throughput if you're doing a lot of frequent changes and constant changes to data, to be able to keep keep up with high throughput. Now, it's storage and cloud agnostic. So if you want to use Hadoop, you can use Hadoop. If you want to use cloud object storage, you can use cloud object storage. It's agnostic to what you're using as your storage. Okay. because at the end of the day, it doesn't reference the files where they're stored. It just references, hey, where's the metadata found? And it's up to the engine to know how to read that address. Okay. It's cloud agnostic. So if you want to use Azure, you want to use Google, you want to use AWS, you can use a Nessie catalog. So it gives you portability among all the different clouds, on-prem, off-prem, or in the cloud. You can use Nessie. Now, as far as like potential cons when you're using Project Nessie, is that right now it mainly supports iceberg tables and views. Okay. Now, while it does have a spec for supporting Delta Lake, there have been efforts to make changes in the Delta Lake repository in the Delta Lake project in order to create that support for Nessie. It's not quite there yet. Okay. Those changes have not been merged into the Nessie project, and I do think that since those pull requests were originally requested, there probably will need to be updates. So in the future, you probably can support Delta Lake. It can support currently a forked version of Delta Lake, but mainly has full support for like iceberg tables and views, and then currently no support for Hoodie. Although if you understand like how Nessie works, adding support for other things isn't the craziest thing in the world, because essentially all it's doing is capturing a little metadata about where to find the definition of the table. So with the, you know, uh, that support can expand pretty easily in the future. Okay, it precludes using other iceberg catalogs. This would be your iceberg catalog. So if you're using AWS Glue as your iceberg catalog, well, you'd switch to Nessie. If you're using some other iceberg catalog, you have to switch over to Nessie to take advantage of these benefits. Okay. And a benefit I didn't put in the green is that also there is a cloud managed service for Nessie. So you don't have to deploy your own Nessie server if you don't want to. Okay. Oh yeah, it is there, cloud managed service. But basically you have a cloud managed service for Nessie, dremioarctic, that can basically provide you all the benefits for you without you having to set up, deploy your own server and maintain your own server. They provide the Nessie catalog for you. And you can catalog all your tables there, get a nice UI that allows you to audit those tables. It's pretty cool. Okay. But it does require an additional service. So there's this additional service, the catalog service, that is running, whether you deploy it yourself or you use a managed solution like dremioarctic. Okay. So overall, those are the details when it comes to Nessie. So with Nessie, you have basically you can do a lot of things at a multi-table catalog level, which allows for high throughput and a lot of that access through SQL, making it very accessible for more people. Because again, out of everything, SQL is going to sort of be the easiest entry point for most data professionals. So that's the story there. Then you have table level commits. So the Iceberg spec has table level versioning built in. So you can create branches at the table level. So each table's metadata can actually track, hey, you've made these references, you've made these tags. Now, a unique thing about the way it's implemented in Iceberg is that generally branches are made not necessarily to be long-lived. They're not meant to be like this thing you're using forever. So when you create a branch, you oftentimes have to specify like, hey, I want this branch to have like a life of 7 days, a life of 14 days. And then after that, that becomes just another invalid reference, like an expired snapshot. Okay, and then you have to also specify how many commits. They're not just like you have to kind of define their scope a little bit more. But you can do that. So, and then let's go to the pros and cons. One of the benefits of this is you don't need any other service. It's just part of the actual metadata that's in the Iceberg table. So you could be using any catalog you want with Iceberg and be able to take advantage of versioning at the table level. Okay, but it supports single table transactions. So essentially, you can isolate changes to the table on a branch, but if you wanted to do like multi-table transactions, you can't do that currently. There is work being done to create a spec for multi-table transactions in Iceberg. When that gets implemented, I don't think all catalogs, it is going to be a sort of a catalog level implementation. And not all catalogs are necessarily going to have support for it right away. But that's going to take some time to be developed. So right now, you can only do single table transactions via the table level versioning. So I could isolate ingestion to a single table. So if I were doing operations across multiple tables, I'd have to create a branch for each table, then make the changes each table. And right now there isn't a way to keep that consistent because I'd have to do each merge operation separately. And generally you don't merge it, you do this fast forward operation. that currently cannot be done through SQL. So basically, right now, in order for you to merge the data, you would have to switch over to like Java and do a fast forward operation. So not, which is Java, not necessarily the easiest entry point for everybody. But you can create branches through SQL and then Spark be able to like switch between the context that you're working in through there. It's just when you want to do that merge and say, hey, this commit moves over to the main branch, that you'd have to shift over to Java to do that fast forward operation. Okay, you can roll back, you can tag, but again, it's all at a single table level. Works with all catalogs. Again, that's a nice benefit there. So if you're using AWS Glue Catalog, you're going to get that table versioning. If you're using HDFS catalog, you're going to get that table versioning. It doesn't matter what catalog you're using. It doesn't require an additional service to be running, and it's storage and cloud agnostic. Because again, the Iceberg format doesn't care where your data, but basically what cloud, where your data is stored, at all. So it doesn't matter what cloud, it doesn't matter what storage system, so whether it's object storage or a Hadoop, it doesn't matter because Iceberg is just it's a metadata layer over wherever your data is stored. So that's why Nessie and the table level spec don't care about what your data is stored, because at the end of the day, they're just storing references. The Iceberg metadata is storing references to the files, and the Nessie catalog is storing references to the metadata. Okay, but it's Apache Iceberg only. So one downside of the table level versioning with Iceberg tables is that it's Apache Iceberg only. So if you have other things, you can't use it. So again, in the future, Nessie may have support for other things, but this is a native Iceberg thing. No multi-table transactions yet. Again, probably down the line it will have that. Multi-table rollbacks, that I don't think is in the currently in the works. Like the multi-table transactions is about trying to create like commits that are simultaneous and consistent, but that doesn't necessarily is different than necessarily being able to go back and roll back commits across multiple tables in a consistent way, and then no multi-table tagging. So these things you'd have to tag table separately, you'd have to roll back table separately, but you can get to the same place, just probably more tedious. And then there's file level versioning. Okay, so this would be like with like Lakehouse. And now the way this works, it's not capturing it's not capturing different states of the metadata. So it's not, so while Nessie's capturing like references to the metadata, and Iceberg is capturing its own states of its own metadata internally, what Lakehouse does, it captures the state of your table. So essentially here we see commit 1 makes up of file A and file B. That's what's currently in the file system in that commit. And then in commit 2, well, we've added file C. So basically that is going to be the commit 2. But then in commit 3, we see that we've added file D and removed file B. Okay, and then I can go back to these different states to kind of restore my file system to those things. Now, again, an individual Lakehouse table may have hundreds of files just for one table. So you're capturing sort of a lot more individual objects in a sense. Okay, you're not necessarily capturing like, this is not like Git where you're capturing like lines of code changes. You're just capturing, hey, these are the files that are in here at this time. Okay, because you're using S3 compatible object storage. So basically, all of that is immutable. Everything in S3 are immutable files. So basically, every change is a sort of a snapshot. So it's taking advantage of that. Now, pros to this approach is that you have multi-file transactions. So essentially, it's not looking at your tables as tables. It's just looking at your file system where all your tables exist. So if you were to create a branch and then make changes to all your tables from that branch, again, it's not recognizing that as tables per se, but it is recognizing that, hey, these files have changed, and those file changes are not on the main branch, and then you can go over there and merge them on the main branch. So you can do essentially multi-table transactions through this sort of multi-file transaction support, because again, it's tracking files, not tables. Okay, same thing with tagging. You can tag a particular state of your file system. You can roll back your file system to a previous state. It works with Delta and Hoodie. Okay, and no format. So not only does it does work with Iceberg, and I'll get back to some nuances as far as how it works with Iceberg. But you can basically, your Delta and Hoodie tables, they're generally more, everything is kind of in the file system. So in that case, they just work. Apache Iceberg, again, you have the catalog and the data files. So there's these two mechanisms that are not necessarily housed in the same file system. So there's where you generally run into an issue with Lakehouse. So traditionally, like if I were to, you have two problems. Okay, one is that if I were to make a change to the iceberg metadata, like let's say I were to do like a rollback from Lakehouse of the file system, okay, and I roll back my file system to a previous state, that doesn't necessarily update my catalog, because my catalog has a separate reference to what's the current metadata file, and it's still going to have the existing reference. So then what happens, you would have like things would kind of get out of sync. The second problem would be that the way Lakehouse as a branching works, it works through the file path. So it uses the, I think like it's like it's referred to as like dynamic pathing in S3 in the S3 spec. So essentially, you'd have a file path, and then in there would be like the branch name, main, ETL, whatnot, and you would sort of create a different branch name in the path. So then what happens is that if you were to merge in changes, it's going to have problems seeing files that have an absolute file path from like a different branch. So Lakehouse solved this problem by creating their own iceberg catalog, Lakehouse catalog, okay, which can be used. Again, the catch with that is that you have to use Lakehouse catalog if you want to use it with iceberg, which means that precludes you from using all the other catalogs. So that precludes you from like Nessie, AWS Glue, HDFS. You'd have to switch over to this catalog. It just was released, so I don't know really many engines other than like Spark where you'll have support for the Lakehouse catalog. So you could probably use it with like Flink and Spark. But far outside of that, it still doesn't have like that much. Basically, each catalog does need engines to support it to be able to access iceberg tables from that particular catalog. So there's that. You can't use SQL to create or merge branches. All that's done externally. So you can do that through different libraries, through the file path. But again, it's basically the file path is what determines what branch you're working on. But you would create that branch either using like the CLI or Python, whatnot. But there really isn't like S3 commands like a create branch command or a merge branch command. SQL isn't really the way you interact with that sort of merging and branching mechanism. And it does require S3 compatible object storage, which is great if you're using AWS S3 or using ADLS or using Google Cloud object storage, or using like an on-prem solution like Minio. But if you're using Hadoop, okay, then you're precluded from being able to use Lakehouse as your versioning mechanism. In that case, your best bet is going to be using table versioning or catalog versioning with Nessie, since Nessie is storage agnostic. Okay, but so you can see like all of them have their pros and cons. It really is going to depend on your use case and what tools you're using. So here we kind of summarize all of that. So we can say, okay, basically when it comes to being able to isolate, work on a branch, all three options can do that. When it comes to tagging and being able to create like reproducible references, all three mechanisms can do that. When it comes to multi-table operations, so being able to make changes to multiple tables and then merge that in a consistent way, you can do that at the catalog and file level. At the table level, you can't because you're only capturing one table at a time. Okay, rollbacks. And I mean, when I say multi-table operations, that's not just multi-table transactions, but that also includes multi-table tagging and multi-table rollbacks. Okay, so eventually at the table level, you might be able to, in the iceberg spec, you'll have multi-table transactions, although I still think it's pretty much going to be a catalog by catalog kind of discussion. Not necessarily like a universal thing like the branching is, but yeah, that's a conversation in progress. Rollback. They all give you a mechanism to roll back the state. So you can roll back the state of your catalog, roll back the state of your table, or roll back the state of your file system. Okay. Now, are they cloud agnostic? All three should be cloud agnostic. It doesn't matter what cloud you're using, AWS, AWS, Google, ADLS, all good. Okay. Storage agnostic. Okay. Basically, when you're working with Iceberg doesn't care where the files are stored, and Nessie doesn't care where the files are stored either. So in that case, when you're working with like Nessie and Iceberg, it doesn't matter where the data is stored. So you can use them with Hadoop. Okay. While Lakehouse is specifically tied to S3 compatible object stores. Okay, so not just any object store, it has to be compatible with the S3 API. Okay. Table format agnostic. So of course, Iceberg as a table format is not going to be agnostic. It's for Iceberg. Same thing with Nessie. It's particularly for Iceberg. Again, there is this effort to build support for Delta Lake. Um, yeah, basically, um, and hopefully that will eventually complete. And again, there's really no reason why it can't continue to add support for other things. Because again, it's just capturing references and capturing basically each Nessie entity thing. Like basically the catalog is made up of all these um, keys essentially. Like basically every unique table or unique view or unique namespace that it's tracking is under a key. And each key has sort of an object of data that labels like what it is. It's an iceberg table, iceberg view, a namespace, Delta Lake table, you know. So there's no reason why theoretically you couldn't come up with a schema for those objects to track things like a hoodie table or whatnot in the future if someone wanted to make those contributions to the open source project. Okay. But it's not currently mainly works with Iceberg, so it's not table format agnostic. While Lakehouse is, again, all it cares about is the files, so you don't even need to have a table format. You can it just versions the file system and every individual file, which files currently exist in the file system, which ones don't, essentially, at particular points in time. And now SQL operations, again, being able to do SQL operations at the catalog level, you can do everything from SQL. You can create a branch, you can merge a branch, you can create a tag, you can assign a tag. Everything can be done from SQL. In Iceberg, most things can be done from SQL. It's just that final piece of like being able to merge a branch would require you to go into Java to do a fast forward operation. And then with Lakehouse, um, basically creating the branch would have to be done, and any kind of merging, all those kind of operations are happen external. And then like basically what you would do is when you're writing your SQL to create a table, you would just specify your table location and specify a file path that includes that branch. So there's no like sort of native SQL support in the same way of the other two options. Okay. But hopefully this gives you a better idea of sort of like what are the differences between these options and the differences in how they work and the differences of like sort of like where their benefits and limitations are. But yeah, my name is Alex Merced, developer advocate here at Dremio. Hopefully you guys enjoyed this presentation about data lakehouse versioning and how you can do versioning of your data lakehouse at the catalog, table, and file level. And as you can see, when you're using Apache Iceberg as your table format, you have a bounty of options on how to best optimize that. And oftentimes, sometimes you might want to take advantage of multiple. Okay, if you're using projectnessie and you're using Iceberg, you can use both. I mean, you have the Iceberg table and the table level versioning is built in, so you have both. But you know that catalog level abstraction is going to be really convenient. Okay, um, but if you're using something like a Delta or a hoodie, well then Lakehouse is going to be sort of your main option. So with that, I will see you all later on. Again, leave your questions in the Q&A box, and then I will make a separate video going through the questions, which will be emailed out and posted once I have that completed. Thank you guys for coming to this presentation today, and I'll see you all around. Again, make sure to come back next week. We'll be talking about Merce journey in unifying their data. So I'll see y'all later.
Hey everybody, this is Alex Merced, developer advocate here at Dremio with some follow-up answers to a recent Gnarly Data Waves episode. So if you ever want to see previous episodes of Gnarly Data Waves, you just go to dremio.com/gnarly-data-waves and you'll get to this page where you can find the links to watch it on YouTube, Spotify, Apple Podcasts, Google Podcasts. You can see what the upcoming episodes, if you want to register to the live performances, and you can click over here on past episodes. And in this case, I'm answering questions for this particular episode where I talked about versioning when it comes to data in your data lakehouse, talking about how you can file things or version things at the catalog, table, and file level. So I had two questions coming out of that presentation that I wanted to follow up on. First one, are the three levels, Nessie, Iceberg, Lakehouse themselves, transactionally linked in the sense that if an error on one level within an operation will roll back the change across the layers? Not necessarily. There are three separate mechanisms. Okay, so for example, it depends where errors occur on sort of what consistency issues. Although you really shouldn't run into consistency issues based if you understand how Iceberg works. So we'll kind of get into that. Okay, so bottom line is this: when you write to an Iceberg table, The catalog isn't going to update till the whole transaction is complete. So if there's an error in writing files, okay, yes, that's the file. Even if some of the files are written, there's going to be a commit in, let's say, Lakehouse for those files being added. Okay, if the transaction doesn't complete, like okay, the catalog doesn't get updated, there isn't going to be a new commit at the Nessie or table level. Okay, so even though you have that commit in, let's say, Lakehouse, because there's some additional files being added, it shouldn't affect your future reads of the iceberg table, because any tool you're using to read iceberg isn't reading it based on the file system. They're reading it based on the catalog and which metadata file the catalog references to. Okay, so if there's a mistake anywhere in the transaction is just not going to complete, because you have those asset guarantees when it comes to iceberg. Now, when it comes to other formats, like Hoodie and Delta, I guess theoretically you could have partially written files, but again, at the same time, if you're taking a look at Hoodie or Delta, there's updates to a sort of central place. So with Hoodie, it's a timeline. With Delta Lake, it's going to be a Delta log file, and those things aren't created until everything else has kind of happened first. So that's why you have asset guarantees with all three formats, and because you have those guarantees, and because of the asset guarantees in the three formats, you're not going to run into issues, because either the transaction completes, and that mechanism, again, the catalog, okay, in Iceberg, or the Delta log file in Delta, or the timeline in Hoodie, they won't get updated unless the transaction completes. So then any reads are not going to necessarily be inconsistent. In worst case scenario, you have a file commit, again in Lakehouse, but that shouldn't affect the reads of the table format, because the table format basically details what's going to be read elsewhere. So, you could always just roll back that commit. But they don't sort of interconnect in any kind of way, in a sense. Okay? Cool. Next question. File level version question. Can they be stored on AWS file storage? The slide data requires S3 compatible object storage. So basically, my interpretation of this question is that they're referring to any kind of other non-S3 methods of storing files on AWS. Okay, and bottom line is, my understanding of Lakehouse is that it requires S3 compatible storage because it's using S3 spec features to execute sort of its versioning. So the idea is that it's using the dynamic URL feature. So other file systems that don't have sort of dynamic file pathing in that sort of S3 fashion, that mechanism just wouldn't be possible, because it's leveraging that. So basically, if I were to spin up a Hadoop cluster using EMR, even though I am using AWS, Lakehouse wouldn't be able to handle versioning of any files on that Hadoop cluster run through AWS EMR, because it's a different file storage. I can use a Nessie for that, because again, at the end of the day, a catalog or table format are agnostic to where the data is stored. It's not leveraging anything. It's not leveraging the storage mechanism. It's essentially all around metadata. Okay, and then the reading of that metadata. So that's basically answers those follow-up questions. Again, make sure to head over to dremio.com/data-wave so you can see what other episodes we have coming up. So here are the upcoming episodes. Okay, next Tuesday we're going to be talking about how Maersk is building a next-gen data lakehouse with Dremio, which is going to be really exciting, because you're going to hear stories about how, you're talking about like very high, like let's say 80% cost savings when you adopt Dremio, when it comes to sort of like different use cases. So you definitely don't want to miss that, to kind of see really like not only how Dremio can like improve performance, but also and ease of use, but also really saves on your bills at the end of the month. Okay, then next week, basically a lot of us will be doing the Apache Iceberg office hours, where you guys come in, you guys ask Apache Iceberg questions, we give you Apache Iceberg answers. And we got plenty of more episodes coming on the way, so make sure not to miss it. I'll see you all there. Have a great day and enjoy.